And we now have another question via telephone. Let me just remind everybody again that if you want to ask a question, all you do is press *1 on your touch-tone phone. And if you'd like to email one, send the question to webcast@nsf.gov. We have Rachel Cortland from New Scientist on the line. And Rachel, when you get connected, go ahead and ask your question.
Great, thanks. You mentioned that there have been 2 previous episodes. Have those been seen in the same area? And I was also wondering if you could describe a little bit more what physically is going on that causes this atmospheric event to spread, and whether there are any Earth analogs.
Well, the 1995 event we have only very sketchy data on. This was before the era of adaptive optics that Mike was talking about, and we really don't have a good idea of exactly where that occurred. The 2004 event we covered in rather good detail, and it was not in exactly the same location as this event. We don't really know yet, as Mike was saying, we don't really know yet what is causing these events. We can rule certain things out just from the fact that we've seen several of them in this time period. But we have suspicions. We think that it is likely tied to something going on the surface, some type of geologic activity. And Cassini has been returning evidence that Titan's surface is geologically active, but nobody's yet really found the smoking geyser or the new mountain range forming to say what that activity is yet. And that's one of the key things over the next few years, and looking for more of these events and trying to pin down exactly where they initiated from, and using Cassini data to look at those points on the surface.
And to be fair, one of the other authors on the paper, Tapio Schneider here at Caltech, thinks that you can have these sorts of atmospheric outbursts simply caused by the atmosphere itself, and no need for something going on the surface. So there's still a lot of uncertainty about what causes these, and this is why if we see more of them, and if we see exactly as you asked, if we see them repeating in the same places, it will become pretty clear. Back in that one that Henry talked about in 2004, we saw a lot of repeating activity in one spot, and it was pretty clear something was going on there. We haven't seen anything else in this spot, but I'd be willing to bet that if we keep staring, which we will, we'll see something else happening right around there.
So you guys go ahead.
I want to emphasize that it's really at this point in terms of our understanding of what's causing the start of this event, initiating it, we really are just at the suspicions level, and absolutely it could be atmospheric, it could be surface, and that what we really need to do is observe multiple more of these events to be able to distinguish between the different possible scenarios that are out there.
Oh, and we didn't answer the question. The other question was what exactly caused all the clouds to spread everywhere, and if there's a analog process on the Earth. And absolutely there is. Henry and I were joking at the start of this that we would never actually use the phrase Rossby wave, but here I go. They're called Rossby waves, or planetary waves, that move in the atmosphere, and they are big. You can essentially think of them as if this were going on in the ocean, and you had some big explosion in the ocean, you would send these big waves going across the ocean, but these are now atmospheric waves. They behave a little bit differently on Titan because Titan rotates so slowly. On the Earth, the Coriolis effect from the rotation causes these waves to bend and move, but here on Titan they propagate even better. So the fact that you had this explosion here could cause these waves all the way around and these clouds everywhere.
And those waves can form the clouds at other latitudes from where the initial formation was. And we also saw a neat thing where we think what happened was the wave circled around Titan and came back to the original cloud and boosted it up about 2 weeks later after the original event. It re-strengthened the cloud when the wave had circled around the moon.
So let me step back and ask you guys to go a little bit more into the adaptive optics, because adaptive optics are not new, but these observations clearly represent sort of a next level. And it's exciting for those of us who are looking through ground-based telescopes, because it brings a lot of capability to all these scopes that are here on the ground. What exactly was done? Is this something new that was done on Gemini, or is this something being done all over? And how do the adaptive optics work?
Let me give my spin on this one, because I think the adaptive optics, as you said, is no longer a new technique on telescopes. It's been almost a decade where we've been able to do this where we see something through the blurry atmosphere and we use a very fast mirror to correct what the effects of the atmosphere and come up with a nice, crisp picture. And this has been going increasingly well over the past decade. And the most amazing thing to me, and Henry's been leading the Gemini effort here, and so I get to sort of watch on the side as it happens, and so I get to sort of watch in amazement, which is that adaptive optics works so well these days that it's almost routine, is that we can get these observations, when we know something's happening, we can get these observations now night after night after night after night after night, because the Gemini telescope can say, okay, we'll do a few minutes of adaptive optics, get these images for these guys, and then we'll go on and do something else, because it's no longer this special technique that requires a team of 15 people to get it all to work. It's just yet another tool in the astronomer's bag that can be used routinely at telescopes like Gemini. So it's an amazing change in the way astronomy can work these days.
That's right. I think actually our first adaptive optics images of Titan that I took were 10 years ago this fall, and those images we would have a whole night on the telescope, and we would spend hours getting set up and tweaking, and then you'd have a few minutes of everything working, and you'd get your image. And nowadays it's about 15 minutes of telescope time at Gemini, so it's quite possible to ask for only a few hours of time over the course of 6 months and split it up into little chunks and get observations on many nights. And that's been a huge development. That's part of the reason we're at Gemini. There certainly are other large telescopes out there with adaptive optics, but Gemini is unique in being Q-scheduled such that we can ask for 10 or 15 minutes of time on many, many nights. You simply can't do that on the other big telescopes.
Do you have any added capabilities on the other scopes that now that you've got the adaptive optics, that there are things that you're hoping to see that you just hadn't been able to see before? Either one of you.
I'm sorry, I didn't quite understand that.
If you've got, now that you have these adaptive optics capabilities and they're really well, they're performing well, do you have other scopes that you're hoping to tune towards other areas of the sky to see things that just you had not been able to see before? Regardless about the time that you're now able to devote, are there capabilities that are now open to you that weren't before?
So adaptive optics is now capable of being used for almost anything in astronomy. And the biggest new development in adaptive optics, of course, is not just the ability to correct anything in the Earth's atmosphere, but it's the ability to send a laser up into the top of the atmosphere, watch that laser, and as that laser light comes back down, take that pulsating laser light and turn into a little spot and correct anywhere. So in addition to studying things like Titan, we've been using these laser adaptive optics to look at things like satellites of tiny little Kuiper belt objects out in the outer part of the solar system, where if you look at them with normal telescopes, you see just one little dot. Suddenly you flip the laser on and turn the switch, and that one little dot turns into 2, or in our case, 3 little dots that you can see circling around the object. So in the solar system, it's been tremendously useful, and astronomers from the solar system out to the edge of the universe have been doing similar sorts of things.